This is a little bit last minute, but I wanted to just take a minute and go over some of the things that it's been a long time since we've done, and one of them is balancing. So I'm going to go over this balancing equation with you really quickly. What we're going to do is I'm going to start by making that what we called a T chart. Do you guys remember that? So we make our little cross here. And I'm going to start on my reactant side, and I'm going to try to put everything that's on my reactants, and I want to be mindful of my polyatomic ions. So I have aluminum here, and I have SO4, which as a reminder is the polyatomic ion sulfate, SO4. And I have calcium, and I have OH, the polyatomic ion, which is hydroxide. And so when I go to make my list here, I can see that I have 2 aluminums. So I start with that. I have 3 SO4s because it's outside here. So I know that I have 3 of them. I have 1 calcium and 2 hydroxides. When I go to the other side, I want to keep my list in the same order. So I'm going to keep this Al, SO4, Ca, and OH because that's going to make everything easier if those are in the same order. And so I'm going to go through and check, okay, I have 1 aluminum. I have this time 1 SO4. I have 1 calcium, and I have 3 hydroxides. So at this point, it's time to start balancing. And so what I'm going to do is I'm going to look at the hydroxides actually first. I immediately notice that they're in this 2-3 position. Maybe we'll wait on those. Let's start with our aluminums. There was really no reason that I decided to wait, except for that I remember that the concept I gave you guys was parsimony. Remember, the simplest answer is probably the right answer. So we're going to start with the simplest thing to fix, which is aluminum. Okay, so I would want to put a 2 here, a coefficient, that's the word for that, vocab term, coefficient of 2. So times 2 gives me 2 aluminums, and then that distributes to my hydroxides, remember? Making them 6. Okay, so my hydroxides have become 6. I know it's a little glary, sorry. Okay, so now I want to fix my SO4s. So I'm going to do that over here as well. I'm going to put a 3, a coefficient of 3 in front of calcium. Remember, I have to put the coefficient all the way in the front. I can't plug it in the middle or on the outside because that has to do with how the compounds fit together in the first place. So I have to just leave it on the outside. So 3 times 3, oops, sorry, times 3 to give me 3 here. And then that also affects my calcium, making it 3. So now I can take a second, I can come back over here and try to figure out what to do with my calcium and my hydroxide. Again, I'm going to take the parsimony tactic. I'm going to fix the easy thing first. I'm going to put my 3 right here. Times 3 gives me 3 calciums, and parsimony wins again. The simplest answer was the right answer. 3 times 2 gives me my 6 here, and everything is all balanced out. So when we do balancing, it usually is, and I'm not going to give you any particularly difficult ones, no multiplying by 2 or anything too crazy. It's just going to be a nice simple balancing equation like this one. And so when you get to the end of this, now we can name these compounds. So if we look at this one, the name of this is aluminum sulfate. And some marker issues here. It's the end of the semester. Aluminum sulfate, aluminum sulfate. This one, guess, tell me what it is. Think about it. What is it? It is calcium hydroxide. Can you name this one? It's got aluminum and hydroxide, so its name is aluminum hydroxide. And lastly, you've got this one over here, calcium sulfate. This would be a good time to remind you guys that in case this is the problem that you guys get for your end of the semester question, you may want to have your polyatomic ions marked or bookmarked or in some way accessible to you so that you can quickly grab them for a reference. All right, see you guys later.